Hello, my name is Wahid Lutfi. Welcome to MyWebUniversity, or welcome to my YouTube channel at MyWebUniversity. In this session, I'm going to discuss the Linux system architecture. So let me go through a slideshow. So on the first slide, you can see the Linux system architecture. And basically on August 25th, 1991, one of the students at one of the university at Finland, and basically his name was Linus and Benedict Torvalds. He actually was the student that sent his email, which you're going to see on the right side. The email was basically asking fellow developers to see if they can just kind of test the same version that Linus Torvalds was working on to see if they like or dislike anything in Linux operating system, and then maybe give their feedback back to Linus Torvalds. And then as a result, Linux first version was born. And then this email, even though it was back in 1992, and as you can see on the email, he wasn't sure where this one would lead, because it was planned to be a hobby, just to test something. But as you can see, Bash and GCC and other stuff was already greatly tested by Linus Torvalds. And then as a result, and the project becomes such a great project, such a novel things to do. And then when you have good intention, which he did at the time, he shared his knowledge with fellow developers. And then the open source and open source community also got built. The GNU utility came as a result of developing. The GNU utility was already on back in 1969 was already Ken Thompson and Dennis Ritchie was working on AT&T version of Unix, and GNU, SED, and awk and other utilities that were there, including the GCC compilers and GNU C compiler. All of those ones were utility that was introduced by GNU, but it becomes such a big part of GNU Linux or GNU Unix. And so GNU Linux is just, GNU is not Linux, but it is a set of utility that you install it. And as a result, this Linux was introduced in 1992. The first version was introduced in September of 1992. And then I was working at the web hosting company at the time, or basically we were doing development, and Red Hat was there. There was other version, but Red Hat just took off with open source community. And then later on, now Red Hat is bought by IBM, but it is a lot of other Linux version, like Linux Debian distribution, Linux Red Hat distribution, Linux Fedora distribution. And then for the Debian, for example, there's Linux Mint, Linux Ubuntu, and many other versions, as well as there's a lot of open Linux, or like OpenSUSE version of it that is there. Caldera and other ones are no longer, I don't see them anymore. But a lot of the companies that Cobalt and other ones, they may have just merged with other companies to become a bigger Linux company. So at this time, I'm going to talk more on the Linux system architecture. As you can see in the middle, the hardware is there, and then this arrow that's pointing to the hardware. Basically, in this example, I'm showing a computer. A computer usually have memory, CPU, input/output, which is for display, keyboard, mouse, etc. Disk storage, and then other peripherals like bus and other peripherals for network connection, and all other ports and everything that is available on a computer. But normally on top of a computer, you're running some software. The hardware it is just a rigid hardware, piece of hardware that could be gates, could be disk, could be RAM, could be anything, and that is just solid hardware. It is you can touch it, but the software is codes, it's binaries and numbers, zeros and ones, basically zeros and ones of bits of code that could be translated to a source code, could be translated to executable code, could be text file, could be image file, anything could be software. And one of the main software that every computer should have is the operating system. The operating system basically operates the system. And then the operating system contains a lot of components. One of the main core part of operating system is the kernel. So in Linux kernel, basically you have the Linux kernel, which is the core part of the operating system that talks to other to the hardware. Basically the kernel responsibility is to talk with the hardware on behalf of the users and make requests and then fulfill the request if it is valid. If it's not valid, it tells the user kind of like a prompt of a message that is what is the status of that request. So the kernel also contains daemons. For example, and the daemons are some of them on Linux, Red Hat 7.6 and 8, or called System D. System D is one of the main process that replaced the previous version of 6.6 and earlier that was init. Init was the mother of all processes, and then now init is on System 7, which is systems Linux System 7, 8, and up. All of them are running, including the Debian Ubuntu version that is System D. So System D is one of the daemons, the schedulers, another daemons. There's a lot of daemons that are checking for processes and daemons and that are for firewalls and for other ones. We will discuss those ones as well as outside of it. And then the kernel also have a set of device driver because it interacts with the hardware. It is basically responsible to make sure that it recognizes your USB drive, it recognizes your memory, how much memory you have, what kind of CPU you have, what's the speed of it. All of that one is being recognized because you have the device driver of the operating system that when you install it and the kernel loaded all the device driver. And sometimes you have to update the device drivers. And then there's also some part of the device drivers, and because it has to be very fast and efficient to work with the hardware, they're written in assembly language. The majority of the Linux kernel is written in C and C++ codes, basically. So the C is the mother of all languages. Even C++ and Java and Python, everything else was written in C. So AT&T Bell Laboratory version of Unix also was written in C. So C is maybe 70–80% is C language, and then some of the assembly code and firmware level of the kernel are written maybe in assembly language. And those are something that we will discuss later on as well, that how fast and efficient those device drivers are in order to communicate with the hardware on behalf of the users. So on the right side, I'm listing all the hardware that you can see for a PC or computer, personal computer or server or workstation or a desktop. And then on the left side, the software components are discussed, which are operating system, the kernel, the shells, and then the GNU utilities, compilers, databases, and interpreters, applications, security, and network software. And then I'm also suggesting here is that software runs dynamically using the hardware resources. So you have these hardware that are available piece of hardware, and then just whether CPU, memory, some component of that one. And then the software, which is these programs or binaries, runs on top of the hardware, and they just do some process, and then execute them, and then complete them, and then you get the output. But as you can see on the red container here, I draw it as if it's a container. It's like almost like software is not physically exist. This bits of zeros and ones that are coming dynamically at runtime, and it gets loaded into memory. So that's why I put that into a container here, because, and it is hot. It's a red color because I wanted to make sure that you understand that software always is either in the two state, either is saved on the disk as source or binaries, or runs on memory as executable files, or executable binaries, or executable application or process. So here we are talking about a number of things, and let's get to the next slide, which is outside of the kernel also talks to the shells. So the shells on Linux platform, there's a number of shells. Originally, the Bourne shell, SH is the Bourne shell, was introduced, and then the superset of Bourne shell, Kernel shell, was introduced, and then Bash, Born Again shell, is the latest version of SH and Kernel shell, called Bash, Born Again shell. And then there's also ZSH, which is the graphic part with Bash and TC shell put together. So Z shells is basically more kind of up to date with everything that you want to do on the shell script. If you like C programming language, you would do more like a shell of CSH or true C shell. This is a true C shell, is an enhanced version of C shell, or a superset of C shell. And similarly, a Kernel shell is a superset of SH, Bourne shell, and then Bash is a superset of SH and Kernel shell, and Z shell is a superset of Bash and TC shells. So that's where your shells are. So what is the job of the shell? The shells are a command line interface to the user. So the user work with the shells in order to make a request to the kernel to talk to the hardware. We just have a command line interface. Whichever shell we use, we write the command and syntax for it, and then it talks to the part of it. So when you install the operating system, the first thing it gets installed is the kernel. Then it gets to install the shells. Now let's get to the third level. After it installed all the shells, now it installed the GNU utilities. GNU is not Unix. That's what this recursive, but there's a set of utilities. For example, make, vi, vim, ld, and grep, set, awk, gawk, knock. All of these one, gawk stand for GNU awk. This originally awk was written by 3 people, and then all of those people, and then watch my other videos for the details of each of these commands. I'm not gonna go on each commands again, but I will discuss this interface. From the kernel, you're talking to the shells, and outside of the shells, you have all these utilities and programs and application. So application, you could have any kind of application. VNC, you could be running like Apache web server, you could be running Xerox doc share application, you could be running some other application. There's so many of them that you could be doing for type of tools that you would be using for application. A lot of companies, they produce software, whether it's Oracle, whether it's MySQL, whether it's some other names. All of them are just writing those tools for you to interact with them through their application, and then work with it. In addition, you have compilers. So like, for example, the GNU utilities, we have GCC, which is GNU C collection compilers. That is a combination of C and C++. So for C++ is G++ compiler, and for C is GCC. In addition, for compilers, you have Intel compilers, for example. You could just have Intel version of compilers, or Borland compilers. you could have all kind of different companies make compilers, and then you install it, and if it works on x64-bit, it should be working on Linux if it was built to be portable on Linux platform. In addition, you have interpreters, for example, Python interpreters, Perl interpreters. A lot of the Python interpreters that you nowadays use on Linux, the latest one is 3.10, I believe. And then I have some of them are 3.8, 3.9, 3.10, and 4 is coming out, so it might be already out. But you need to test the interpreters also. In addition to interpreters, sometimes you have like PyCharm IDE, integrated development environment, or Borland C or Visual Studio C compilers and interpreters that you could just get them and just run them. And then interpreters are basically different than compilers. Compilers are a set of source code that you compile it together as one page or many pages of code. Interpreters, one line at a time, it gets translated. So if you have 10 lines, each line runs individually and test it before it is giving you the output of the final one. And then obviously for each line that you run, you will get an output if there's no error. And compilers, on the other hand, as a source code of one page, if it is 10 lines, the whole 10-line syntax will be checked, the semantic will be checked. If there's no error, then it gets an object file gets created. Then from that object file, you get to compile it to create an executable, and then the executable code is the time that run. And if you have any errors at runtime, it will show. So that's the difference between compilers and interpreters. And you also have a set of security software like SSL, secure socket layer, or TLS, and then secure SSHD, and then the firewall D could be like an old version of Red Hat 6.6 or earlier is IP tables, and now it's a firewall D on system 7. And then on each of these, whether it's Ubuntu, like Ubuntu firewall D is there. So each one of them, they have different set of security software as well. And then you have daemons on the outside here as well. Notice that there was daemon for systemd and schedulers and other stuff on the kernel level, and there's daemons on the application side that you could just run. For example, if you're running Apache web server, I mentioned it, then you could have the Apache HTTPD process, or secure SSHD, secure shell daemon, or FTPD for file transfer protocol daemon, or VNC, the virtual D for virtual environment D. And then Oracle has a lot of system related daemons, at least 6 of them: log writer, DB writer, and system writer, system, and other stuff. But let's talk about MySQL, for example. MySQL D would be the daemons as well. So the database, you could have a list of database running, and then database could be Informix, MySQL, Oracle, and then anything. You could just run it. And GNU, we talked about it. The grep and egrep and fgrep, I already have videos on these ones. Global regular expression print, these are also part of the GNU utilities that was introduced to just do piping. And then awk is the programming language, NOC is new awk, and then gawk is GNU awk. Sed is stream editorial, that is also come with the operating system. VI is a visual interpreter, and then VEM is VI improved. That's why IM is in uppercase, but the actual command is VI M all in lowercase. VI improved. AS and LD and make or utilities or binaries that you could run to compile your code, and then run a make file to build from source code. This is also part of the GNU stuff that was introduced to make your system be able to just compile code. And for example, the GCC wasn't done here, or G++, but at the same time, you want to use those ones with the make, and so you could build the whole project when you build a project like Git or GitHub or some other tools, even like just building Apache from source. I have a video that is on the internet already that you can see how I built Apache from the source using these AS, ALD, and make and all the things with all the commands I showed it. So this is the outside. As you can see now, that interaction at the start from the hardware here, and then the software, every component outside of this kernel, every component is belong to the software. So this three circle that are there, the first circle is the hardware. I'm sorry, there's 4 circles, but the first one is hardware. The second circle is the kernel. And then the third one here outside of the kernel is the shell. And outside of that one is application and utilities, database, compilers, and so on. So all of that details are here. When they run dynamically as container on the operating system. So when you are looking at your computer display output, you're seeing what is loaded already onto RAM. Whether it's your command line interface that you're working on a shell, or you're running a command like make, or compiling something, or running Python, or opening up a database table, reading and writing into that database table, or just working with an application to draw some CAT application or anything. The application could be a number of thousands of different applications. I named a few of them. But here, the last part of it is the user interface. So in this case, I put some of the users, like 4 of them, including myself. But the main one on the left side is the developer that started this great project, Linus Torvalds. And then he basically just started with this thing. And now even Bill Gates, Microsoft, you can see here, Bill Gates is even using some sort of a screen here to demo that, hey, we can port Linux onto Microsoft Windows. And as a matter of fact, we already have it. So Linux subsystem is already on part of the Windows subsystem, and then you could run it as a kind of container. You can also run Linux on top of Windows as a virtual machine, or even inside the virtual machine, you can have containers such as Dockers and other ones. You can just test those ones. And the possibility is limitless, even though at one point Linus Torvalds said that, okay, we may not have too much at this time, that's all I have, but he introduces the whole word everything. God bless you, and you did a great job here. So and this lady, she might be just using her laptop, or either working for boss, other company, or just having her own business. She is maybe using Linux, maybe using Windows. It is there. And I'm just one of the system analysts or system developers or software engineer. I do everything, whether it's Windows, Linux, programming, application, bringing you these videos on a YouTube channel. So please make sure that you go to our YouTube channel, which is MyWebUniversity free education videos, and then just watch these videos and make some comments so I can improve it based on your needs. And then as you make comments, please make sure also, if you haven't subscribed yet, subscribe, so we could just inform you. YouTube is automatically going to inform you as soon as I post a video. Thank you all for watching. Thanks for your time. I appreciate it. Have a nice one. Take care. Bye-bye.